surfaces. Po. Ano, sige po. Wait lang guys. Okay, sorry guys. So why do we need to study about fluids? So fluids are also used to reduce friction. So fluid mechanics is a branch of science that deals with the study of fluids or liquid or gases which is at rest or in motion. So the study of fluid that is in motion, so siya ay tinatawag na fluid dynamics. Okay? Pag ang fluid natin ay in motion, fluid dynamics, while at rest is fluid statics. So yun nga, yung nakapasa na kayo sa fluid mechanics, diba? So, fluid mechanics has a wide range of application in mechanical and chemical engineering. So, and it is associated sa fluid machinery. So, kaya nandito kayo ngayon sa aking subject is kasi nakapasa na kayo lahat sa fluid mechanics. So, sa fluid machinery is the principle and theories for proper operation, selection, and application of the most commonly used blowers, compressors, and turbines. So, yan nga yung unang example ko. So, ito yung sa PPD nyo. So, parang pag meron ba kayong PPD na or next sem?
Fourth year
So,
pa po.
fourth year pa. So, yan. One of the power plants. So, ang tawag dito is hydroelectric power plant. So, katulad nito, turbines. So, turbines na nandito. So, si turbines, isa sa ating fluid machinery. So, ang hydroelectric power plant natin, so electricity produced from generators driven by turbines that convert the potential energy of falling or fast-flowing water into mechanical energy. So, makikita nyo, meron tayong intake dito. So, may flowing water tayo dito. And flow siya sa penstock. So, si water, tumama sa blades ng ating turbine. So, si turbine, yung fluid machinery natin. So, pagtama niya, umikot si turbine. So, si turbine naman, nakakonect siya via shaft sa ating generator. So, kung iikot si turbine, iikot din si shaft, iikot house and transformer, and si transformer, so itatransmit na yung electricity na na-produce sa transmission lines, then i-distribute na sa ating bahay-bahay. Okay? So, next, characteristics of fluid. So, there are 5: compressibility, density, pressure, buoyancy, and viscosity. So, compressibility. So, applying pressure to a fluid in order to put greater mass into a smaller container. So, gases and liquids vary in these characteristics. So, gas is more compressible than liquid, but some liquids are considered incompressible. So, ang compressibility daw gives an idea of how a fluid volume changes when subjected to a change in pressure or external force. So, yan, yung pag nag-exert tayo ng external force, so nagre-reduce siya or nagdi-decrease yung kanyang volume, and yung kanyang particles is nagiging tighter, diba? So, all materials, whether solid or fluids, can change their shape under the application of external force or stress. So, in case of fluid, the force is generally termed as pressure. So, ang pressure as it is uniform from all direction. So, but how do we judge the solid or fluid is susceptible to change in the volume upon application of force pressure? So in simple words, compressibility is a measure of change in the volume of fluid under the effect. Okay? So yan. One of the basic example for compressibility is the bicycle tire pump. So si bicycle tire pump, compressed gas. So when you use a bicycle tire pump, you're introducing compressed air into the tire. So increasing its pressure and causing it to expand. So which results in a firm tire ready for riding. So another application ng ating compressibility, so as engineers, so another application ng ating compressibility, so includes pwede siyang aeronautical. So bakit sa aeronautical? So understanding air compressibility is vital in aircraft design, mines, hydraulic system, and pumps. So yan, kung gusto niyong maging piping engineers in the future. Next one, thermodynamics. So essential for studying phase transition and behavior of. Okay, next one, density. So density is a very density is defined as the mass contained in a unit volume. So the more precise name for density is volumetric mass density. So yeah, see density is a fundamental concept in physics and engineering. So not only is it is intimately tied to the mass of an object, but density is also central to determining whether something will float when placed on a surface or of a liquid or it will sink. Okay? It mag-float or nagsisink. So, the importance of density, pwede din siyang buoyancy. So, density, so no, different than density sa buoyancy. Ha. So, density has obvious importance when it comes to the buoyancy of object. So, broadly, if something is denser than water, it will sink. So, pag mas mataas yung density ng ating object kaysa sa water, it will sink or lulubog siya. But if something has a lower density than water, or mas magaan, or mas mababa yung kanyang density than water, then it will float or lulutang siya. So formula for density, so density is equal to mass over volume. Yan. So more technically, something will start to float when the weight of the water it displaces. So due to the surface area making contact with water and how far it pushes the water down. So matches the weight of the object. But if this never happens, it will sink. So ang good example dito. So yan. Kita nyo, hindi siya nagme-mix, di ba? Yung sa ng ating cylinder is haluin mo siya or mekos-mekos po yung nandyan sa loob hindi siya mamimix. So, babalik ulit sa ganyang form. So, then water, yung fall stretch out will fuck with water. So, however, so if you roll the same amount of foil up into a ball, so the surface area in contact with water becomes much smaller and the mass is concentrated above it. So the greater density of aluminum wins out and the foil will sink. So kaya yung ating mga boats or mga bangka made of denser materials than water will float. So the whole structure has a lower density than the block because it contains a lot of air or less dense material too. So next slide is, so dito, we differentiate niya o pinapakita niya yung mga molecules or particles. So yung behavior, if siya ba ay gas, liquid, or solid. Okay, admit lang natin. Yan. So it also illustrates the difference between molecules of gas, liquid, or solid state. So solid state is denser because its molecules or particle is tighter than liquids in gases. So if an object fluid is made of heavier atoms or molecules, or the particles are packed more closely together, then it's going to have a higher density. Okay? So, meaning pag ang ating molecules is yan, nakapack together or tighter, mas mataas yung kanyang density. So, next one, pressure. So, fluid pressure is a measurement of the force per unit area on an object in fluid or on the surface of a closed container. So, since a fluid has no definite shape, its pressure applies in all direction. So, mararamdaman na, I mean, hindi niyo siya mararamdaman. So, katulad sa inyo, meron kayong nararamdaman or merong pressure na tumatama sa inyo pero hindi niyo siya nararamdaman. So, fluid pressure can also be amplified through hydraulic mechanisms and changes in the velocity of the fluid. So, pressure, it is defined as force divided by the area on which the force is pushing. So, basic formula can be written as pressure is equal to force over area. Example dito is when a person or animal or fish swims, so water presses against all sides of them. So they feel equal pressure from all directions. So near the ocean surface, the pressure is the same as what we feel when standing on the land. So this amount of pressure is called an atmospheric pressure. So the term is used as unit of measurement. So it's the pressure of Earth's full atmosphere pressing down on us at the sea level. Yan yung example ng pressure natin. Meron daw tayong lateral pressure, downward pressure, and upward pressure. So, itong upward pressure, ito yung ating buoyancy. So, itong lateral pressure, wait lang, mag-ano tayo. Yan. So, makikita niyo dito at equal depth. So, di ba, may hole dito, binutasan. Nasaan na yung ating pen? Yan. So, dito at uh, may depth tayo na dito natin binutasan yung ating water bottle na may water. Then, meron distance. Yan. Nakaka-capture ba? Ayan. So, yan. Nagda-drawing ako, guys. So, ito, yung distance ng ating, what do you call that? Yung pressure, meaning mataas. Since mas baba yung kanyang depth. So, katulad ng mga scuba divers, pag nagsiswimming kayo, so pag na-reach yung bottom of the pool, sumasakit yung tenga nyo kasi mas mataas yung pressure at the bottom of the pool. Pero pag dito natin inilagay yung hole, yan. So, dito. Meaning, mas mahina yung kanyang pressure. So, ang distance lang niya ay, yan. So, dito lang siya. So, from dito to dito lang. Mas mababa yung distance since mas mahina yung kanyang pressure. So, as you travel, so katulad din yan nung pag-travel ng sea level to a higher elevation on land, atmospheric pressure drops. So, that's because there's less air above you pressing you down. Okay? So, katulad din ng underwater pressure or yung ating hydrostatic pressure. So, the more water you have above you, the more it pushes against you. So, but water doesn't only push down from above, it pushes in from all sides and even from below. So, meron din tayong upward force called buoyancy. So, buoyancy, it is what keeps you afloat in water. So, imagine, so kadala ng lateral pressure. So, yan nga, a diver. So, diver swims straight down from the surface. So, as they go deeper, their ear clogs. So, sumasakit na yung tenga niya. di ba? So it is the same feeling you get when you drive up into the mountains. So, di ba, pag pumunta kayo ng Mountain Everest, nag-hiking kayo, ganun din, sumasakit din yung tenga niyo. So, this happens because there's more pressure on one side of the eardrum than the other. So, the diver has to swallow or wiggle their jaw to make the pressure equal on both sides. So, this is what happens when you pop your ears. Okay, so ganun siya. So, pag mas malalim, balita niyo na wala pang nakakarating sa mismong floor ng ating ocean. Kasi yung mga devices natin, yung mga yung satellites, yung satellites kayang mag-contain sa mataas na pressure. Kasi ultimo, yung, for example, yung kanilang, what do you call that, submarine. So, mag-explode yan. Kahit yung submarine mag-explode at the bottom of the ocean, pag hindi na niya kaya or hindi na masustain yung pressure doon, mag-explode. Kahit kayo, mag-explode. Hanggat meron, search nyo yung diver na napalalim, then hindi niya na kaya, nag-explode yung katawan niya because of pressure. Okay, next one, manometer. So, it is a device to measure pressure. So, a common simple manometer consists of a U-shaped tube of glass filled with some liquid. So, yung typically, the liquid inside the manometer is mercury because of its high density. Next one, buoyancy. It is the tendency of a body to float or to rise when submerged in a fluid, testing an object's buoyancy. So the power of fluid to exert an upward force on a body placed in the water is called buoyancy. So upward force yun na ang buoyancy natin. So meron tayong formula for buoyancy na buoyant force is equal to fluid volume times fluid density times gravitational acceleration. So, yan. Yung example ng ating buoyancy. So, have you ever looked at a giant ship and wondered how such a heavy object made of steel floats in water? So, bakit nga ba nakaka-float yung mga malalaking barko? So, for a ship to float, it must have lower density than water, di ba? So, dapat mas mababa yung density ng ating object para maka-float siya sa water. So at first sight, this might not make sense as the ships are made up of steel or it is not exactly known for its low density. Di ba pag nakita nyo, ang bigat-bigat naman ma'am ng steel, bakit yan ay nakaka-float? So hindi. So the thing is, the density of an object results from the relationship between its total volume and its weight. So, hindi lang tayo nagbe-base dun. So, meron din tayong katulad ng Archimedes principle. So, if the total volume of a ship is large enough in relation to its weight, it has a low density. Okay? Or to simply put this one, because of all the air spaces inside, a ship has a lower average density than water, despite the heavy material it is made of. So another example for this one is the well-known Titanic. So alam naman natin yung Titanic, diba? So Titanic collided with a massive iceberg. So bumangga siya sa isang iceberg. So in less than 3 hours, lumubog si Titanic. Okay, totally submerged sa water. So the massive side impact caused enough damage on the water to flood into 16 major watertight compartment. Meaning, may pumasok na water sa loob ni Titanic. Kasi syempre bumangga ka sa iceberg. Ngayon, nagkaroon ng massive impact or damage and within less than 3 hours, lumabog because of ng water. So, kumbaga, di ba, water density. Di ba, ang density ng water. Then, nagkaroon, di ba, sabi kanina, air spaces. Air spaces inside the ship. Yun yung Kaya nagkakaroon tayo ng lower average density than water. Eh ngayon, pumasok na yung water sa loob ng ship. So kaya si Titanic ay lumabog. Okay. Next one, viscosity. So viscosity, it is a fluid's resistance to flow. So the more viscous a fluid is, the harder it is to make a fluid flow. Or the thicker the fluid, the greater its viscosity because less viscous fluids are easier to flow. So ito yung formula ng viscosity. So viscosity is equal to shear stress over shear strain or rate of shear deformation or yung ating velocity gradient. So, an example nito is si water in si syrup. For example, in-steer nyo si water. Diba? Ang dali-dali. Dali-dali mag-steer kasi si water, meron siyang low viscosity. Ang dali nyong mahalo si water. So, minsan gumagawa pa nga tayo ng ano nga yun, tornado. Diba? Parang tornado. Ganyan. Pinapaikot natin. Eh, si syrup or honey syrup. O, imagine nyo ha, na may honey syrup kayo sa isang container. Then, in-stir nyo, hirap na hirap kayo. Oh shit, ang ano naman ito? Ang lapat ba yun? So, yan. In-stir nyo ang hirap kasi si honey or syrup, meron siyang high viscosity. And another viscosity, pag low viscosity daw siya, more flow daw. Pag high viscosity, less flow. So, anong ibig sabihin nito? More flow and less flow. So, for example, meron tayong, imagine niyo may hawak kayong ketchup and may hawak kayong water bottle. Then, ang ginawa nyo, uh, hinold nyo upside down yung water bottle. So, allowing the water to flow. So, ang bilis, di ba? Ang bilis na ubos ng tubig na nasa bottle. Eh ngayon, trinay nyo sa ketchup. Hinold nyo upside down, then binuksan nyo yung taklob. Ang hirap, di ba? Kahit pag kumakain tayo, ang hirap, kumbaga, ang hirap palabasin ni ketchup sa loob ng kanyang bote. Ginawa nyo, tinuktok nyo yung end ng bottle ng ketchup para lang tumulo, para lang lumabas si ketchup. Ang hirap pa din. So, ang ginawa nyo, clinose nyo ulit, kinalog nyo si ketchup, then upside down. So, yun yung sinasabing less flow, konti-konti. So, ibig sabihin si ketchup is meron lang siyang high viscosity. Well, si water, meron siyang low viscosity, meaning pag low viscosity, since malabnaw nga siya, ibig sabihin, more flow siya. Okay, next. Type of fluids. Yan. So, ideal fluid. So, ideal fluid is incompressible and it is an imaginary fluid that doesn't exist in reality. Also, it doesn't have viscosity. Okay? So, itong ideal fluid, also known as the perfect fluid daw siya. So, nobody's perfect, diga, kahit tao. And kahit si fluid, wala. Hindi, ibig sabihin, it doesn't exist in reality kaya siya tinawag na perfect fluid. Pero yung iba ha, yung iba, kino-consider nila ang water as ideal fluid. So, no. So, sa tunay, di talaga ideal fluid si water or hindi siya perfect fluid kasi si water, meron siyang viscosity, kahit maliit lang yan meron siyang super, super low viscosity. Kasi si ideal fluid, siya ay no stress or no shear stress, no viscosity, no heat conduction, or ideal fluid is not found in reality. So it is termed as an imaginary fluid since all the fluids that exist in our environment have some viscosity or have low viscosity. Therefore, there is no ideal fluid in reality. Eh, ma'am, bakit nandyan yan? Bakit nasa PowerPoint natin yan? So, ito, dinidiscuss natin yung types ng ating fluid. And dito, based sa graph, so, kumbaga, pang-test siya. So, ito yung ideal fluid. Wala kang na-measure na viscosity, wala kang na-measure na shear stress, and wala kang na-measure na heat conduction. So, para lang siya sa testing. Okay? Kaya tayo may ideal fluid. Yan. Next one. Real fluid. So, a fluid which possesses at least some viscosity. Kahit konting viscosity lang. Kahit super babang viscosity na 0.0001 na viscosity. So, real fluid na yun. So, actually, lahat ng fluid na nag-exist or present in our environment are called real fluid. So, halos lahat. So, siguro alam niya na naman kung ano yung mga fluids. So, yun ay considered as real fluid kasi nagpo-possess sila ng kahit konting viscosity, kahit super liit o super babang viscosity pa man. Next one is Newtonian fluid. So, the fluid whose viscosity remains constant is also known as the Newtonian fluid. So, ano ba si Newtonian? So, according to Newton's law of viscosity, ang shear stress daw is directly proportional to velocity gradient. So, the shear stress between the two adjacent layer of the fluid is directly proportional to the negative value of the velocity gradient between the same two adjacent layer of the fluid. So, meaning, ito, uh, also the viscosity totally depends upon the temperature and pressure of the fluid. So, sa Newtonian fluid, so sabi nga kanina, it is the relationship between the viscosity and shear stress. So, pag linear siya. So, katulad ng, ang example nga dyan kanina is yung sa viscosity, back to viscosity tayo kanina, yung example natin na minix nyo or in-steer nyo si water. So, di ba pagka-steer nyo kay water, uh, ganun pa din pag tinigil nyo, ganun pa din yung kanyang viscosity. So, pag minix nyo, ganun pa rin. So, walang nagbabago. So, meaning, ang kanyang viscosity and shear stress o yung ating fluid daw ay linear kasi wala nagbago. While si non-Newtonian, so ayan, if the real fluid does not obey Newton's law of viscosity, so kabaliktaran siya or opposite siya ni Newtonian fluid. So if the shear stress is not proportional to the shear strain or velocity gradient, then it is called non-Newtonian fluid. So ang example dito is honey, soap solution, cosmetic, and etc. So for example, so kung kanina sa Newtonian, ang in-steer natin is yung water, diba? So ang daling ma-steer kasi linear siya. So si honey, in-steer natin, mapapansin nyo, uy, parang ang dali, dumadali. Pag habang tumatagal, dumadali mong ma-steer siya, di ba? Kumbaga, parang siya ay lumalabnaw. So, katulad yan ng mga soap solution. So, lumalabnaw siya. Then, tinigil mo. Tinigil mo yung pag-steer. Iniwan mo siya ng 30 minutes na nakaganon. Wala kang ginagalaw. So, nakita mo, binalikan mo after 30 minutes, trinay mo ulit siyang steer, haluin, ngayon ang hirap-hirap na. So, meaning, nagbago yung kanya ulit viscosity. Eh ngayon, ang ginawa mo, in-steer mo siya ulit. O, ang nangyari, yung viscosity, nagbabago. Uy, parang dumadali yung pag-steer. Or kumbaga lumalabnaw, ang dali na. Then, iniwan mo ulit, ganun ulit. So, yan si non-Newtonian fluid. Yun yung isang example for non-Newtonian fluid. Next naman, ito ang ideal plastic fluid. So, where the shear stress becomes proportional to the velocity gradient and more than the yield value. So, the fluid is said to be ideal plastic fluid. So, ang example naman nito is yung water suspension of clay and fly ash. So, for example, yung clay natin. So, di ba, may nagkikli yung pottery. Magpa-pottery kayo, then basahin tubig, ganyan. So, makikita nyo pag na-absorb na ni clay si water, so magiging nasa solid state na siya. So, yun yung ideal plastic fluid. Next, last two, incompressible fluid. So when the density of the fluid remains invariant with the application of external force. So it is said to be incompressible fluid. While compressible fluid, when the density of the fluid varies with the application of external force. It is a compressible fluid. So coming from the word itself, incompressible and compressible. So hindi daw siya makakompress kasi invariant siya with the application of external force. Okay. So, may questions ba? Clarifications? Or may nahihirapan lang intindihin sa slides?
Malinaw naman po.
Malinaw naman. Okay, sure kayo ha na wala kayong questions, clarifications. So, yan. So, kung wala ng questions, so kung may, sorry pala, kung nahihiya kayo magsabi dito, so pati nyo naman akong i-message through messenger na ma'am, medyo hindi ko na-gets ganito, si ganyan. So, okay lang. So, siguro for today, so hanggang dito lang muna yung atin. Then, tomorrow, i-discussion ulit tayo. Tomorrow, ha? So, online. So, siguro okay na yung schedule nyo. Then, yung other schedule ko kasi is conflict. So, try ko din i-reach out si Ma'am Joanne ulit. Kausapin kung final na ba yung schedule niya talaga. Okay. So, yan. So, kung wala ng questions, clarifications, so, ibabalik ko yung remaining time nyo. So, para mag-prepare sa next class nyo. Then, tomorrow, we will have a discussion regarding Bernoulli's. So, start na natin siya. Recap ulit tayo ng mga Bernoulli's equation, continuity equation. So, yan. Okay? So, kung wala ng questions, yes pa. Ano po yan?
Ma'am, ano lang po, tatanong ko lang po kung mag-upload po kayo ngayon ng PPT po.
Okay. So, itong PPT na to. Sige, upload ko na siya sa inyong
Sige po, ma'am. Thank you po.
Okay. So, kung wala ng questions, clarifications, thank you, engineers, and have a nice day.
Thank you po, ma'am.
Thank you po, ma'am.
Thank you, ma'am.
Thank you po.